Alright, here we are, the aftermath of the next morning. Aircrete City. Little problems. Problem with my manifold here. The joints weren't tight enough, and there's gaps. Little air leakage. We'll have to repair that. But did manage to make some Aircrete. These are 2x2 by 2 foot triangles. Two different mixes. One on the left has sawdust as a cellulose filler added to it. It's a little bit thinner. It's finished. Now you see there was some leakage on the side. It was scraped off. On this side we have a straight Aircrete mix with added Easy Sand 20 for quick setup. Didn't slump much at all. This is the one I'm hoping will be a good lightweight, fast setup type mix recipe for large panels, which after I see what comes out of these two will be attempted. You'll notice that they're dirty, but there are tracks built in to these panels, and one is male, one is female. So these panels will interlock. There's a possible way to do geodesic panels. We'll see how that comes out. So here it is, prototype on my Aircrete project. I'd like to do some shout outs here to Honeydew Carpenter, of course. Crazy son of a gun has gotten a lot of people fired up over this stuff. The next one would be Aircrete Harry. Saw him last year doing some stuff and disappeared for a while, and then now he's back. And Honeydew Carpenter gave me the idea for the tracks. Aircrete Harry gave me the idea on the recipe changes to the Aircrete that I'm looking for. And of course, this is a conglomerate of that's, you know, your basic foam foamer assembly. This is my large capacity fluid holding tank, I guess, and my Aircrete gun, which is my foam gun, which is a basic takeoff on your basic foam gun design. Under here, oh, there's some more tracking. What are we gonna do under there? Oh, I don't know. That's for the next video. You gotta wait and find out. Some ingredients, and back to you, Chet. Yes, first of all, another shout out to Lil Pig, as I call him, LittlepigStore. Lil Pig. He's the one that turned me on to adding the Easy Sand as an accelerator for a no slump formula, which would be this one here. and we're going to see how that rolls. It's only 12 hours old right now, and it's warm, humid climate, so everything's kind of very wet, very lightweight. This is some of the seepage on a different formula, and it is very, very light and very brittle so far. So we're going to see how this all sets up. When I find a successful formula, I will be utilizing this larger panel. My reason for doing the Aircrete is different. It's not for structural, it's for insulation panels. I have a project that was going to use 4-foot by 8-foot extruded polyethylene foam panels for insulation, and they have jacked the prices on all that stuff so high that it would cost me $1,000 to do the project I need to do just to buy the foam panels. That's just too much money. So what I'm trying to do here is come up with a system that will provide me with my 2.5 inch insulator panel that'll be relatively lightweight and will still provide me with my, R8 of insulation, which if you notice the figures on what people claim on R values and K values, etc., that the extruded foam paneling per inch and the Aircrete per inch R values are very similar. So my goal is to produce large lightweight panels that are structural enough to stay intact, obviously, and that can be used as a layover rigid insulation panel. With these tracks also, of course, with the design I'm working up here, these will be interlocking via this tracking, which is actually just 7/8 standoff ridge for metal roof installations. Like I said, here we have the male version, here we have the female version. Here's a female version on this. How is this made, you may ask? Well, you see down here, we have some cutoffs done with that metal cutting wheel on the radial arm saw. And here are your 4 corners. And this is some of the cutoffs from some of the 60-degree work that was done on the triangles. These are just the ends. You'll notice that this one, they're complete. Every corner comes off in one piece. The trick, while I was working this, that I figured out, is to not cut all the way down to the bottom. We leave a gap. Can't really pick this up on camera, but there's a gap there. And that gap leaves that bottom piece of metal intact. And this gives us our form leaves those bottom edges, and after you've cut your 45s, you just take them, fold them up like so, right? I don't want to do this too often because I don't want to fatigue my metal. You fold them up, and you have your mitered corners. That's why I do figure out my cuts, my measurements, so I have an overlap on the bottom, especially since home dipsticks can't seem to keep straight pieces straight because of their rough handling. They only had 2, so this one, as you can see, was pretty mauled at the end here, but it works just fine. You know, as my overlap. A couple of screws in here, and we're good to go. So that's the newest project here. Like I said, my goal are going to be interlocking rigid insulation panels to be used for projects. This particular panel here is going to be a 35 by 35 inch panel. Had I thought about it, it probably would have downsized it to a 32 by 32, but I wanted to get the largest panel I could cut out of one 12-foot piece of steel. And 35 was about it. Okay, so like I said, because they only had 2 pieces, I needed 1 piece for those, and I used 1 piece for this. And after I inspect the mixes, after they harden up a couple of 2-3 days, we'll figure out which mix I want to go with for the large panel, and then we'll set up and pour on the large panel. And that will be the next project. Thank you very much, and back to you, Chet.